Hi guys, so for today's lesson we're going to be dealing with the 68, 95, 99.7 rule. So I know it's a bit of a strange name, but we'll get to why it's called that. Okay, so if you are dealing with normally distributed data, so remember from last lesson that's a data set where the mean, the median and usually the mode are all roughly equal. They don't have to be perfect, but they're all quite close to each other. So when your data set is like that, 68% of this data set should lie between one standard deviation of the mean. So that pretty much suggests that with your data set, like that's going to be a whole heap of different numbers. 68% of those numbers are going to lie between one standard deviation of the mean. So let's do an example to kind of hopefully make a bit of sense of this. Okay, so e.g., a normally distributed set of data has a mean of 10. Its average is 10, and standard deviation of 3. Okay, so when we're graphing this sort of thing, it's really important to be able to go from your mean and standard deviation to some sort of bell curve. It doesn't matter how skinny or fat it is. First things first, put your mean in the center. So our 10 is in the center at the highest point of our bell curve. And down the bottom, we don't want to just use random numbers. We want to use our standard deviation. So notice I started with 10 in the middle, and I want to go up and down by this number of 3. I want to use that as my scale. So 10, then 13, then 16, then 19. I'm going up by 3 each time. And then I'm going down by 3 each time. So really important to apply that. Okay, so using that, we want to use this rule. 68% of data lies between one standard deviation of the mean. So what I want to do is go up and down by just one standard deviation, one lot of 3. So I get to 7 and 13. Now, in between these numbers 7 and 13, so in this area here lies 68% of my data set. So I'm saying that 68% of data lies in this area here. And you can kind of see that like in this area, you're going to have really large columns which represent a lot of data. This is going to be a majority of my data in this section. And so roughly 68%, that kind of makes sense. So that is the first rule to remember. 68% lie between one standard deviation of the mean. Okay, so next up, I also want to kind of consider, it's really important to also consider these areas here. So this area on the side here and this one on the side here as well. These are still important for a lot of questions. So what you do here to figure out these percentages over here is where you think to yourself, well, the entire curve, so everything under the curve, so this whole part here, that represents 100%. And I'm going to take away the 68%. So if I get rid of this section here, it leaves me with these two ends here. And then if I take that away, and then I'm going to divide my answer by 2, and that will leave me with just one of these parts. So if I do that, I take away my 68% and then divide it by 2. That leaves in 16%. So that kind of suggests that the percentage that lies in these end parts is going to be just 16%. So I'll put a 16% there and a 16% there. So some really important percentages that we can get from using our first rule of our 68, 95, 99.7 rule. Okay, let's move on to the second rule. So rule 2, 95% of data lies between 2 standard deviations of the mean. So that suggests that if we go up and down from the mean, so remember that your mean is just here. If you go up and down by 2 standard deviations, so 2 lots of 3. If you go up and down by that, so I'll go down there as well. So we kind of get our boundaries here and here. We're going to be having 95% of data in between these numbers. So Yeah, and that kind of makes sense as well. A large majority of data is going to be fitting in this section because a lot of the columns are significantly taller in this area. So we can use this rule to also find out the percentages in these end sections. So we can go 100%, take away this section, and then divide it into two parts. And we get that each of these smaller sections is going to be equal to 2.5%. So again, these numbers are really important for a lot of questions in this topic. And then lastly, we've got the Rule 3, which is the 99.7 rule. That is the percentage that lies between 3 standard deviations of the mean. So I'm going 1, 2, 3. I'm going up by 3 and then down by 3 lots. And in between these numbers here, you've got 99.7% of data in between. And we can use this number here to figure out the percentages in these end sections, so above 19 and below 1, by taking this away from 100%, then dividing by 2, and that leaves me with 0.15%. Okay, so a few more percentages that will help us out a lot. Now, there's an additional rule that you need to be aware of. 50% of data is above and below the mean. So this one here is a little bit easier to see. So there's our mean there. We can see that half of the data, half of the curve, is above that number 10, and 50% is below that mean as well. So these numbers do help us out with a lot of questions as well. Okay, so let's apply some of these rules to a more practical sort of question. Okay, so the distribution of delivery times for pizzas made by House of Pizza, some sort of pizza business, is approximately normal. And it has a mean of 25 minutes and a standard deviation of 4 minutes. So, first question is what percentage of pizzas have delivery times between 17 minutes and 33 minutes? So let's try to get our head around what's happening here. So they're saying that roughly this business can deliver pizzas in 25 minutes. That's the average time. But obviously you're going to get pizzas that take longer and shorter than 25 minutes. So the standard deviation is 4 minutes in this case. So because it's normally distributed, you can represent this data as a bell curve, and you're going to have your average in the center, so like this. So that's the first thing you need to be able to do, is to draw this sort of distribution. You want to make sure that you're going up and down by your standard deviation of 4 minutes. So I'm going starting from 25, the average. I'm going to go up by 4 each time, and I'm going to have at least 3 lots of standard deviation going up. And then also I do the same thing going down. I'm going to go down by 4 each time. Okay, so we want to figure out the percentage between 17 and 33. Notice that those numbers do occur on our graph. That's usually going to be the case. Okay, so let's apply one of these 3 rules that we've learned about. So we want to deal with the 17 and 33 minute marks, because that's what our question is dealing with. Now we need to notice that that these two numbers, well, 33 is going up by 2 lots of standard deviation. So 2 lots of standard deviation there, and the 17 minute mark is going down by 2 standard deviations. So pretty much we're trying to figure out what percentage is in between 2 standard deviations of the mean, and that relates directly to the 95% rule. The 95 rule. So pretty much from our rule 2, we can read off that that 95% is between the 2 standard deviations of the mean. So our final answer is that 95% of deliveries is between 17 minutes and 33 minutes. So pretty much if you're getting business off from this company, you can kind of be 95% sure that it's going to take between 17 and 33 minutes. That's kind of the idea. There's a 5% chance that it's going to be outside this range. Okay, so let's try another one. What percentage of pizza has delivery times greater than 29 minutes? So when we draw our graph, we want to try and figure out what percentage is going to be larger than 29. So pretty much this section here, what percentage is that? So we're using this number here. First thing to note is that 29 is just one standard deviation above this mean of 25. So when you're going just one standard deviation above, you're going to be dealing with just the 68% rule. And if we remember how to figure out these sections on the end, we can go 100%, we can take away the 68% to be left with just these end parts, and then divide that by 2 to be left with just 1, and then we get left over with 16%. So that suggests that only 16% of deliveries are going to be larger than 29 minutes long. So that is going to be your final answer because we're just after the percentage. Question C, a bit trickier. In 1 month, House of Pizza delivers 2,000 pizzas. How many of these 2,000 are delivered between 13 and 25 minutes? So we're dealing with this number here, 13, and this number here, 25. We want to know what percentage is between these two numbers. So the way to do it is to firstly deal with this 13 number here. So that is 1, 2, 3 lots of standard deviation below the mean. When we're dealing with 3 lots of standard deviation, we're dealing with the 99.7 rule. So we firstly need to figure out how we're going to use that rule. So what we can do, well, our strategy is to realize that, well, if we know that this whole section here is 50% of the data because that's below the 25 mark. So we know that's 50%. If we can go 50% and take away this little section here, that gives us the percentage of what is kind of shaded in here. So the idea is we want to figure out the percentage in this tiny little section here and take it away from 50% to figure out exactly what's between 13 and 25. Okay, so the percentage which is less than 13, this tiny little section here, we can take away the large 99.7% area because that's the 3 standard deviations away. We can take that away from 100% and then divide it by 2 to figure out this little part here. And that leaves us with 0.15%. We pretty much did it up here in Rule 3. So if I go back to Rule 3, you can see that these little sections here are 0.15%. It's just using this working here. So that will find out that is a little 0.15% there. And then we can go 50%, take away that little section. So 50% take away the 0.15%. That leaves us with 49.85%. That is this blue coloured shaded area. Really important to be able to find out that percentage. That is critical to finding your answer. We don't want the percentage, however. We want to know how many of these 2,000 pizzas were between the 13 and 25%. So step 2, we use the percentage that's between our 13 and 25. We use this percentage here and we apply it to the 2,000 pizzas. And this will give us an exact number of pizzas between 13 and 25 minutes long in delivery. So that as a decimal is going to be equal to that. And I multiply by my 2,000. And that comes out as 997 pizzas that were sold between 13 and 25 minutes. So there's a couple of parts to that question. It can be difficult to find the perfect percentage that you need, but the more practice you do, the better you'll get at it. Good luck with the questions. Bye.